Welcome to Chapter 8, which is going to teach us a little bit about statistics. And here we are, we're starting in the first section here, Section 8.1. And the true title of Section 8.1 is Finding and Organizing Data. But we're only going to focus on the organization of the data. That first part just gets too in the weeds with definitions and things for us. We're just going to focus on working with statistics and so organizing data. So as you can imagine, when data is collected, it's pretty robust, pretty big. And sometimes we need to organize it just so we can see what's going on. And that seeing part is actually really beneficial because it gives us how the data is distributed or how it looks. And so data can be distributed in what's called a normal distribution, right? Where it starts low, peaks early, and then falls off. It could be uniform in all that it does. It could be what we call bimodal, look like that, but it could peak early and fall off. Like all of those are general shapes that we want to be able to see. And so sometimes it's beneficial to see those shapes, and sometimes it's just beneficial just to have the data in a organized way so that we can work with it better. And so there are three types of frequency distributions. A frequency distribution is a table in which we organize data. And so you'll see as we move throughout here that they'll always use these last two words, frequency distribution. And the frequency distribution, like I said, is a table that organizes the data. It displays how many times a data element appears. Okay, so I think this will make sense as we go forward and work in each of three distinct areas. And the first one is a categorical frequency distribution. So categorical is a big word, has different meanings depending upon context, but for us, it means that when we talk about categorical in statistics, what we're saying is that it's not numbers, it's not numerical. It's somehow qualified, right? Qualified data, and they're not quantitative. So qualitative data, it's probably a better way for me to say that. And so let me actually write that down here. So sorry about not saying that just right, but qualitative data. And what I mean by qualitative data is it's giving a quality. But remember, frequency distribution for us is just a table that's going to organize the data to display how many times a data element appears. And so I'm going to go to our first example here. Students in a statistics class were asked to provide their majors and provided the data below. And so you can see what the different individuals said that their data was as they were just participants in a statistics class. As you look at what was collected, words like, or majors like undecided, biology, sociology, political science, education, these are qualities, they're not numbers. And so this is where we're going to do a categorical frequency distribution. So the first step is to list out in any order what was being said. So the back of the book will always do it in alphabetical order. You do not have to do that. So you could start with saying, okay, the first category that I see is undecided. And you're going to write that down. I'm going to write it in a column because remember, we're making a table. Then the next one I see is biology. And I'm just going to go right across the top. So I see undecided, biology. I see another biology. No need to write it twice. We'll get to that in a minute. The next one is sociology, and I haven't written that down. So I'll put that down. Then there's political science, poli-sci. Sociology again, but I have it. Undecided, I have it. Undecided, biology. I haven't had education yet. an education major, biology, political science, political science. And so I've gotten all the different categories that are there. So as we look at this, this would be the major. Often they will label this first column as what the data is collecting. The data is collecting the major. And the second column is always the same thing. I'm going to put an F in there, but off to the side, I'll let you know F stands for frequency. Sorry about that. Pen didn't work super well. So let me get in here and rewrite that. Frequency. Frequency is just how often. So really what we're doing is the first category that we have is undecided. We need to count up how many undecideds there were. There were 1 in that first row, 2, 3, 4. Looks like we have 4 undecided majors when they talk to the group of individuals there. Biology majors, we just count them. I'm going to go in each row. 1, 2, 3, 4, 5, 6. Looks like there's 6 biology majors. Sociology, there's 1 in the first row, 2 in the second one in the second row, and that's it, just those 2. Political science, we have 1 in the second row, nothing in the third row or first row, and then 2 more for a total of 3. 2 more in that last row. So we have 1, 2, 3 political science majors. And then education, I believe there was only 1. So a good way, this is it. This is what you do. This is a categorical frequency distribution that lets you know the weight of each one. You can quickly look at this table and see that biology is the most popular major. Education is the least popular, right? Lots of students are undecided in this process, in their education, this timing of their education. And so this is what a completed categorical frequency table looks like. Now, we could check ourselves, and I would recommend that you do it just to make sure you didn't overlook somebody, which I might have done. If I add up all the frequencies, in this case I have 4, let me write it down here. I have 4 plus 6 plus 2 plus 3 plus 1. So that's 10, 12, 15, 16. So ideally, I have 16 individual responses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's true. So because 16 matches the number of outputs up here, I know that I most likely did it correctly and because I haven't skipped anybody. If it doesn't add up to how many you have, you'll want to go back because most likely you overlook somebody. Okay, so just as a recap, a categorical frequency distribution says, okay, I must be looking at words as opposed to numbers. In this case, majors. I then look and write down every unique major. So undecided, I write down. Biology, I write down once. Sociology, political science, education, because they're in this mix. Then I literally go count them, and that's the frequency. And so we counted 4 undecided majors, right? 1 in the first row, 2 in the second, and 1 in the third. So pretty awesome. And we're done, right? That's the extent of it. So you'll have homework just like this, where all you're doing is writing out the categories and then counting the number of times they happen. So it really is a definition thing. The next one is qualitative. Actually, shouldn't say qualitative. It should say quantitative. Quantitative frequency distribution. That's my mistake for putting that in here. This one is a frequency distribution with numbers, right? Because I should be able to count them. So it's the same thing. I'm going to write down every unique number that I see and then count the number of times I see it. So this is a problem that's in the book. Attendees at a conflict resolution workshop are asked, hey, how many siblings do you have? And then they just recorded their responses. Well, that's kind of a scattering of responses, so what would be best is to organize it in a frequency table. whenever it is given to you as numbers, we definitely want to go, and let me get my pen back. We want to go from low to high. So what's the lowest number that we see? We see a 1. And the highest number that we see is a 4. Now, even if there's not a number 3, which I know you see that there is, or a 2, we still list everything out in between the low and the high. So in this case, let me erase low to high since you have that in your notes. To go right above here and say number of siblings, because that's what our data was. So the number of siblings was 1 sibling, 2 siblings, 3 siblings, 4 siblings. Why am I stopping at 4? Because nobody said more than 4. So we don't have a frequency distribution that extends beyond our data. Second column is always F for frequency. And remember, frequency is a count. So in this case, it's very easy to skip somebody, especially as, I guess it's not super easy, but we want to be really careful. We got to count the number of 1s, then count the number of 2s, so forth and so on. So let's try to do that pretty carefully. We got a 1, counting the 1s, 1, 2, 3, 4, 5, coming through here, 6, 7, 8, 9. Looks like I have 9 number 1s. Now I'm going to go count the 2s. 2, 2, sorry, 1, 2, 2 2s, 3 2s, 4 2s, 5 2s, 6 2s, 7 2s, 8 2s, 9 2s, 10 2s. Now I'm going to count the 3s. 1 3, 2 3, 3 3s, 4 3s, 5 3s, 6 3s, 7 3s, 8 3s. Okay, I'm going to pause there. So on your paper, I can't really do it very well here, but you can cross out or, so you're not having to see so much. But be careful in your cross-outs that you make it so you can still see the numbers that aren't crossed out. And so at number 4, I got to look at 4 siblings. There's 1 in the first row, 2, second one, that second row, third one in the third row, fourth one in the fourth row, and also a fifth one in there. So I'm going to do my same trick again. So first of all, if I go back up top, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then 24, and then 32, right? Yeah, so I should get at 32. So let's look what 9 plus 10 plus 8 plus 5 is. So I get 19 plus 8 is 27 plus 5 is the 32. That's awesome. That's what I should have had, so I counted it correctly. Just wanted to model that way of checking because sometimes I'll get answers on the exam and the numbers are, one of the numbers typically is a little off and is not right. And just somebody got overlooked in that process. So it doesn't tell you who got overlooked, but it tells you it's worth your time going back. But this is the answer right here. This is the quantitative frequency distribution for this set of data here. So it's very similar to our categorical one, right? Here we were looking at words and just counting them up. Here we're looking at numbers and just counting them up. And sometimes, though, our data spans a very wide range. Like this one was small. It went from 1 to 4. Makes a whole lot of sense just to have each single number. But when it gets really big, we do what's called a bend frequency distribution. Okay, and so a bend frequency distribution, let's talk about what that is. This creates a bin of values, right, where it gets its name. Okay, sometimes in books they'll call it classes. So instead of doing like 1, 2, 3, 4, 5, maybe because our data spreads out from 1 to 37, we do something like, hey, 1 to 4. And then the next category is 5 to 9. And then the next category would be, well, let me talk about how I knew it was 5 to 9. 1 to 4 would be all the values from 1 to 4 inclusive. So that would be values that we would count are 1, 2, 3, and 4, right? Would all fit into that first bin or that first category. So obviously the next bin would start at the next number because we want to have a home for everybody and not be questioning which is its home. So it starts at 5. So notice that the distance from 1 to 5 is only 4. So I made a mistake. This should be 5 to 8 because we want those bins to be uniform. So we would go 4 up. So it'd be 5 to 8, right? Having the numbers 5, 6, 7, 8. Notice that the change from 1 to 5 is 4 and that there's 4 values in each of the bins. They talk about that as a bin width. The bin width is, and be careful here, it's the distance from the start of one class to the start of the next. Okay, it's from the start of one class to the start of the next. So if you had something like, hey, 0 to 4, which happens sometimes, we get a 0 in there, 5 to 9, that would be a bin width of 5. The next, it would start at 10 and it would go to 14. Then would start at 15 and go to 20. So let's pause and look at this. Now, how do you know what the bin width is? The book's going to give it to us. They have an example where you're creating the bin width, but when you go to the homework examples, they always give you the bin width. I will do the same thing on the exam. So look what the bin width is, though. The bin width is not 4. It's not 4 minus 0. It's 5 minus 0. It's this bin width right here. It's 5. From 5 to 10 is 5. Notice from 4 to 9, 4 plus what is 9? 4 plus 5 is 9. 9 plus 5 is 14. So notice I'm moving by 5 to get from the start of one to the start of the next, from the end of one to the end of the next. That's where we get our bin width. Why is it a bin width of 5? Because the numbers that would be involved here are 0, 1, 2, 3, 4 for this first bin. That's 5 different numbers. For this second bin, it'd be 5, 6, 7, 8, 9. That's 5 different numbers. So there's a real reason why we call that the bin width. It's because that's really what's in there. So let me show you what you're going to have to do in the homework. They're going to give you a list of data, and they'll ask you, hey, it's numbers. They're going to say, hey, make a bin frequency table, frequency distribution for age using a bin width of 5. So this is the ages of customers who shopped at a new boutique. So the first thing you want to identify is, well, what's the lowest value that you see? And you see that the lowest value that we see is 26. So often we start these things, these bins at something right around that lowest value, and we continue until we cover the highest value, which in this case is, looks like 56. Okay. So let's see what happens here as we use a bin width of 5. So let's start at something like 25. Is that okay? We got to start around our low value. You don't have to start at it. So I'm just going to start with 25. And I'm actually going to erase that for a minute because I want to make sure I do something. And that is label out what the data is. The data is age. And we're going to start out with 25. And they want a bin width of 5. Now I know everybody listening to this video knows that 25 plus 5 is 30. But what I don't know is if everybody's going to do the right thing with that 30. So 25 plus 5 is 30. I'll write that off to the side here. And why am I taking 25 plus 5? Well, 25 was where I decided to start because it was around that 26. Somebody out there might be saying, well, why didn't you start at 26? I could, but it looks a lot cleaner if I start at a multiple of 5 in this case because of the bin width of 5. But I absolutely could have started out with 26. Hey, Jensen, does that mean there's multiple answers? Yes. If I don't tell you where to start that first bin, then there can be multiple answers. So 25 plus 5 is 30. Where does that 30 go? Remember, the bin width is the distance from the start of one class to the start of the next. So 25 plus 5 is 30, so that's the start of the next. So where does the other one end? It ends at 29. Okay, and then you can get the starts, hey, 35, 40, 45, 50, right? I can get all these starts going in. And then there is a 55, so I'm going to have to go up to that bin right there, and we'll see if that covers us. So where do I stop? Well, the reason I knew to stop at 29 for the first bin was because it's one less than the start of the next. So the next one should stop at 34, the next one should stop at 39, the next one 44, the next one 49. Notice 49 plus 5 is 54. 54 plus 5 is 59. Now, I have to keep going if there's a number above 59 in my data set, and there's not. Often when you do these binned frequency tables, the list of data is long. This one's relatively short, but I want to show you something that I like to do. I'm going to go value by value. So you see this 56 up here. I'll try to highlight it here. There's that 56. Well, I'm going to put a mark down here. I'm going to do these tally marks. One mark down here, right, where this guy is. So either inside or outside. I don't know what you'd prefer. If you're going to go outside, I draw these lines a little bit farther. And I'll show you why I'm doing it on the outside. It's not a have to. So I'm just going to go value by value. So 56 is a mark down here at the bottom. I'll just keep making it deeper. 39, right here. 35, same area. 32, one above. 26, one above. 53, second to last. 55, last. 47, right there above, right here. 33, put a mark where the 33 should go. Another 33, a 43, a 41, a 26, a 40, a 31, and a 34. So I really like this method because it's very difficult when you're methodical like this to make a mistake. It is possible, right, to drop something into a wrong category. So be patient with yourself as you go through here. Just realize that the overall process is not going to take you very long. The homework assignment itself is actually not very long. So just take your time when you do it. You'll have plenty of time. The last thing to do, though, you can't leave it like this. You got to tell me what the count was. So there's 2 in that first category. 1, 2, 3, 4, 5 in the next. 2, 3, 1, 1, 2. And it gives us an idea of that bend frequency area. So I'm erasing these tally marks now. You can back up the video if you needed to see it, because they're actually not part of the frequency table. This is the bend frequency table right here that tells us a breakdown in ages of how it's laid out. So that's what you're going to be doing in this first section, is looking at some data that's given to you and organizing it in a categorical frequency table because it's words, a quantitative frequency distribution because it's numbers that aren't very wide, and so you can just do single ones, or they'll tell you to do a binned one and give you the binned width, and we follow this last procedure. So try the homework, see how it goes. As I mentioned, it's not very much, so you should be able to complete it quickly, provided that it makes sense. So reach out with questions if you have them. Thanks for watching.